Okay, in this video, we're going to talk about verifying whether a function is even or odd, and we're going to do so algebraically. So verify even or odd algebraically. Last video, we were able to determine if it's even or odd just by looking at a graph. This time, maybe we don't know what the graph looks like, and we don't have anything to graph it out. We don't want to graph it by hand. So how do we know if this function is even or odd algebraically? And I'm going to have you guys consider two steps to this. Okay, the first step, always start by substituting. And I want you to substitute negative x for x in the original function. Okay, and then your second step, you're going to try to simplify it as much as you can so that you can try to compare it to that original function. All right, so let's remember also that, I'll write this in a different color. Even functions, our rule is that f of x is equal to f of negative x. Odd functions, our rule is that f of negative x is equal to negative f of x. Notice how both of them are comparing something to an f of negative x, which is why I suggest substituting in that negative x first. Okay, so let's look at these three examples. First, we've got g of x equals x cubed minus x. So first step, I'm going to plug in negative x. And I get negative x cubed minus negative x. Notice I'm using parentheses and I'm being specific about where these parentheses go. Right? I didn't put the cubed inside this. I just want to substitute specifically the negative x for that x. Okay, now if I take a negative and I cube it, I'm always going to get a negative answer. Negative 2 times negative 2 times negative 2 is going to give me a negative. Negative 1 times negative 1 times negative 1 will give me a negative. So I can simplify that to just negative x cubed. Minus negative x. Subtracting a negative is going to give me a positive, so I get plus x. Okay, well again, how can I compare that? Our goal is to compare it to the x cubed minus x. Well, let me factor out a negative. If I factor out a negative, then that negative x cubed becomes a positive. Positive divided by a negative is a negative. I get negative x cubed minus x, which is the same thing that we started with. But I have that negative in front, so that is my negative g of x. Okay, if you're struggling to see it, this is your g of x. That negative is what we took out. So now compare that back up to our two rules. G of negative x, where is it equal to negative g of x? And that would be true for an odd function. So A is an odd function. Okay, similarly, we can do the same thing on B. Substitute in negative x for x. So I get negative x squared plus 1. Well, if I square a negative, I'm always going to get a positive. So I get x squared plus 1. Well, that's the exact same thing I started with. X squared plus 1, x squared plus 1. So h of negative x is equal to h of x. And that is our rule for even functions, which tells us that b is an even function. Okay, and the last one, same way as before, we're going to start by substituting in negative x. We get negative x cubed minus 1. Again, just like in A, if I cube a negative, I get a negative. Okay, I'm going to do the same thing, and I'm going to factor out this negative just so that I can get a positive x cubed like I have in my original equation. And then negative 1 divided by negative gives me a positive. Okay, when I factor out that negative, I'm left with a function that isn't the same. Okay, so this is not equal to f of x, and it's not equal to negative f of x. It doesn't fit my even rule. It doesn't fit my odd rule. So this one is neither. And that's that. Let me know if you have any questions.